for making time to be here. And for those who apparently will watch this later, I just learned that this is being recorded for future consumption. So I do see a lot of familiar faces. I won't try to recognize everyone, but thanks for being here. And I was invited to give this talk 6 months ago. It always amazes me that there's still interest in coal ash. So when I get an invitation, I always say, really, you want to hear? I mean, I'm happy to do it, but do you really? So you came, and for those of you who are watching, I hope to make it worth your while. A couple things. The title is Advancing, how UNC Charlotte is advancing. I view this almost like an in-reach presentation, just to make folks aware of what we're doing. It's sort of like the expression that I think was popularized with GE. If GE, General Electric, knew what GE knew, they could be effective. And sometimes that happens here at the university. We have lots of silos. And so that's part of my intent, is to encourage some cross-pollination. But really I want to emphasize, as far as UNC Charlotte advancing, that's not meant to be some grandstanding by the university. Obviously, that's all done with partners. It's done with sponsors. It's done with consulting organizations. It's done with lots of other entities. It's not just us. It never is. And certainly this whole building, I mean, you're sitting in the Siemens Energy lecture hall. This whole building reflects that sort of partnership. And so, too, with a lot of the research we're talking about. And I also changed the, as far as my title, the title that went out, it had, let me see if I can get this to continue here. So it said chair in absentia, okay? So I'm kind of doing a weird thing, right? So I'm chair of the department, but we've got an acting chair named, and that's so that I can principally evolve some things with the Ash Management Advisory Board, as well as a few other activities. But I've changed that term absentia because, I got an email back from a colleague at another university, and he said, John, what the heck does absentia mean? Are you banned from the building? Or, did you do something wrong? And we've got the associate dean here. Maybe I did. But so I've simply changed it to on assignment because the term in absentia, which just, Latin for absent, implies more nefarious reasoning. So anyhow, on assignment. So my intent, what I'm trying to do over the next, and I'll try to wrap this up in 45 minutes so that we can have questions if you want, but a little refresher on coal ash and why you still might care. And so, look, we've got folks who've got their PhDs and PEs and have designed facilities for decades in this room. Do we have folks, and we have folks who don't necessarily have that same suite of expertise. Looking around, we've got folks who just span the spectrum. So I do want to put that into context a little bit. So for those of you who are experts, hopefully I won't put you to sleep. And then within that context, I want to wrap in what we're actually doing here. Look, there's lots of institutions, lots of organizations doing lots of things on coal ash, and we're not doing all of them. And so part of my intent is just to shine a light on what we're actually doing and how we're trying to contribute. Maybe the word contribute's a better word to the broader activity of coal ash management. So Chris already did this. I was going to verify who is here today, but we do have a mix, and Chris asked for those folks to put their hands up with some coal ash experience. We've got a range of folks here. Do we have any attorneys here? Let me ask that. How many, any attorneys here? Okay. Any attorneys watching? Okay, I can't do that because it'll be recorded later. So, anyhow, for those, we do have a range of folks, and it just sort of reflects what's going on. So let me just do some high-level stuff here. And I don't think this, oh, there it is. This is working. So coal is, it's not really going away anytime soon, at least on the world front. So if you look just in the case of the U.S., certainly we're burning less coal. Natural gas is more available, and so it's supplanting coal. And so we get far fewer coal-fired power plants. But if you look at a place like China, virtually 80% of their electricity is still coming from coal. If you look at India, they're actually building more coal-fired power plants. And so here we're declining. India, you're actually increasing. They're building, at one point I heard, at least a coal-fired power plant every week. Indonesia, I mean, if you look at development, if you look at sustainable development indicators and quality of life and this sort of thing, power is instrumental for that. And so these other countries that want the same standard of living as we all enjoy are building lots of coal-fired power plants. So the net effect of all that is if you look at the percent of electricity derived from coal, it's actually increasing still in the world today. So globally, we have a lot of coal. And the bottom line is when you burn coal, of course, you mine coal from the ground, you combust it, you're left with ash. It's a lot of ash. And so nearly 1 billion tons of coal combustion residuals per year on the worldwide stage. So a lot of this material exists. Even if coal stopped tomorrow, even if we were able to have fabulous batteries and we could go to renewables tomorrow, you'd still have a lot of these materials that we ought to deal with, and we ought to use them responsibly. To put this in perspective to where we're sitting now, so this is a Google image shot, and so here we are, UNC Charlotte right here. And so there's 3 plants, and we do have some other experts here. I see we've got folks who could correct my numbers, so forgive me if these numbers are off by a decimal or 2, or hopefully not 1 million or 2. But these numbers that I've got here reflect the short tons of ash in impoundments. And of course, there's other ash in dry facilities. But in North Carolina, 32 ash ponds across the state, and you've got several at any given facility. So we're within 5-7 miles of 22, 24, over 30 million tons of ash from where we're sitting right now. So there's a lot of this material worldwide. There's a lot of this material nearby. And so it stands to reason that if you've got a lot of material and you want to use it, that you're going to engage a university and other consultants, other organizations to help use it responsibly. And so that's the overall context for some of this. So that's what an example of what that could look like. There you have coal ash in the foreground, and you see further beyond a lake. And so a lot of this material, great construction material, fantastic properties. For me, it's always just fascinating because the particles are predominantly spherical. And so if you look at these in electron micrograph, that's the sort of thing you see when you zoom in. We can get into the nuances of this. These ash can vary significantly from one ash impoundment to another. But by and large, you get a lot of these spherical particles. And then when you analyze them and you say, well, okay, well, just what's in those particles, it's predominantly things like silica, alumina, iron oxides, all of these things. The same composition that you typically see in soil, although the morphology is different, much more spherical in nature. Of course, that's not what grabs the headlines, and we'll touch upon that later. But as far as a weight percent, 99% of this stuff is silica, alumina, iron oxides, etc. And so that's a good thing because we got a lot of this ash. And for those, how many civil engineers in the audience do we have? So, okay, so hopefully you saw the ASCE report card. They've been doing this for at least over a decade at this point. And they released it, and America got a D+. Okay, and they estimate, and this is a whole criteria for rating America's infrastructure. And so there's all these things, right, in terms of surface transportation, roads, bridges, wastewater treatment plants, all this stuff. All this stuff takes construction. A lot of this takes concrete. And so looking at what are the total needs and how does that relate to estimated funding that's available, and then what's the funding gap. So if you scroll down all the way to the bottom, ASCE, and they do this all the time, they've gotten more and more precise with their estimates, estimates something on the order of $2 trillion, because these are in values in billions of dollars, so this is $2 trillion shortfall by 2025 in terms of investment. So we need to spend a lot on infrastructure, and ash can be a significant part of that. So, okay, great. So we have a lot of ash, and we need to build infrastructure. That's pretty simple. So who cares? I mean, that's a pretty simple thing to deal with. And so getting back to ash, I mean, you know, maybe I wouldn't be up here talking if that were the end of the story. I mean, it's a construction material. We use it. We need it. That's fantastic. But there have been accidents which have occurred. And I won't go into the details because at this point, most folks have seen this many times. But this was in December of 2008 in Kingston, Tennessee, where an ash impoundment was compromised, and ash was released and filled up the Emory and Clinch rivers. This was in 2014 here, where the Dan River had, in terms of scale and size, it's no comparison. There was less than 1% of the ash from the previous picture that got into the Dan River, but nevertheless enough to raise lots of concern. So what you're looking at there is the Dan River, and it's colored by ash from a release. So those two events led to all kinds of activity, right? So those two events led to the promulgation of rules from the EPA. Took lots of time. Back 7 years ago here in Charlotte, we had thousands of people giving 3-minute statements to the EPA. And even those rules came out in 2015. Of course, North Carolina beat them with the Coal Ash Management Act, and then it subsequently got revised in 2016. And then just recently, just last December, you had coal ash inserted into this huge bill related to water resources development. And so, so ash, in part because of those things, it's triggered an avalanche of regulations and legislation to deal with an issue that for a long time just wasn't on anybody's radar. And so if you think about ash, again, it's primarily a construction material, but because we have so much of it, it's also a waste in many respects. But if you put it in the potpourri of waste types that we've dealt with as a society, you've got things like municipal solid waste, right, garbage. You've got things like hazardous waste, I mean real hazardous waste from legacy industries, and you've got nuclear waste. And the country's dealt with all of those streams through programs like CERCLA and RCRA. And so now it's just really getting around to focusing on this particular stream, which is coal ash. Now, what's interesting to me about this latest bill is that the chief sponsors were, I don't know if anyone's a political junkie here, but you got Barbara Boxer and James Inhofe as co-sponsors of this legislation. I mean, if we had the ideological spectrum where, okay, from where you're sitting, so this would be Barbara Boxer against that wall, and Inhofe would be against that wall, and yet they came together for this bill and inserted language to allow states to have their own coal ash permitting rules such that we don't have to rely on citizen lawsuits and judges to interpret the EPA CCR rule. And that's sort of a mouthful. We can get into that if you want. But the point is, ash and certainly infrastructure can actually be a bipartisan issue. So your next cocktail party or Thanksgiving dinner where you've got different political stripes at the table, think infrastructure. It usually has bipartisan interest. And it certainly has national interest. And so this is a map showing coal-fired power plants across the country. And so I mentioned 32 in North Carolina. Depending on which numbers you go by, certainly a lot more nationally. And so here we're 735 ash impoundments across the country. And that's what the rule really targeted. The rule really targeted those at 557 plant sites. So this is a very old photo. This is not how it's managed. But historically, you would burn your coal. You would collect it with a baghouse filter or electrostatic precipitator, which, as I've just learned this morning, baghouse filter fabrics are becoming far more common and more effective. And you mix that with water, and you would discharge that. So this is ash mixed with water. You send it to a pond. The ash settles out, and then the water goes maybe through a secondary or tertiary pond. It is subjected to a national pollution discharge and elimination system permitting requirements. Treatment is implemented if needed, and ultimately water which meets water quality criteria would ultimately be discharged to the nearest stream, river, lake, and so forth. But this is what those regulations are terminating, okay? In essence, again, it's a bit more nuanced, so for the policy wonks in the audience, it's a little bit more nuanced than this, but suffice it to say this mode of managing ash is done. This mode of ash is in favor. This is what you can do in terms of dry ash handling, which means you're not mixing it with water and decanting it, but rather you are mixing it with a small amount of water, just enough to compact it and entomb this in landfill type scenarios. There's a lot of plants with a lot of impoundments, and the regulations and the legislation, at least in North Carolina, wants all of this done in a certain amount of time. And so the concern is, well, how much does all this cost, and how much should this cost, and are we making the right decisions? And so as part of, and again, we're in the part of the presentation where it's like, well, who cares about coal ash? Well, part of it, there's a lot of dollars at play, and let's make sure that we're investing these dollars wisely as citizens. And so depending on which way you look at this, this could be as much as $10 billion just for North Carolina. Now, this is an older estimate. It hasn't been refined, but I've talked to various contractors and various other service providers, and that number might even be low depending on what criteria you're trying to meet. But if you have 32 impoundments, and if you accept that number, just as a whole number, $10 billion, if we do it the most expensive way conceivable, excavate everything, haul it to some other virgin site and entomb it, with lots of water treatment, then that could be $10 billion just for North Carolina. You take that across the U.S., almost $230 billion. If, again, hypothetically, if you were to do this, and if you did that across the world, it'd be a couple $1 trillion. And just compare that. I mean, just, the world GDP is about 75 trillion. I mean, you can Google this now while I'm talking, but my guess is the U.S. GDP is probably on the order of 18 trillion. And so these can be significant numbers, is my point. And so these aren't trivial details in the grand scheme of things. And so it is important to get this right and to do the right thing environmentally as well as financially so that we can be good stewards. So like I say, some of my numbers suggest that could be higher depending which way or how you deal with water treatment, for example, and how quickly you deal with it. So I'm going to segue soon to what UNC Charlotte's doing, but here's a quote from Cord Wisman. Cord Wisman is he just finished his term as president of the American Society of Civil Engineers Geo Institute. He's also on the board for the Department of Civil and Environmental Engineering and president of GeoPeer up in Davidson. And his quote basically is pointing out that, look, this day and age, we have to be able to convey issues to a broad spectrum of stakeholders. I put this up here for a variety of reasons, not the least of which we've got a lot of engineers in the audience. And, it used to be in this business where you would do an engineering report and you would meet with the regulator, it would go back and forth, and it would be technical jargon, and you just resolve your issues. And everyone understood what you were talking about because they had a shared training, shared understanding of what was being endeavored, being accomplished. But now everything is subjected to 360 degrees of evaluation, internet posting of data, real time, and you are not necessarily sharing information with people who have the same training, the same education, the same agenda, whatever. And so it's important to be able to understand where folks are coming from. And so that quote comes from Cord. I would encourage that. I think that's useful for all of us. And who has not seen this image before? Give me your hand. And please, a little courage if you... No, okay, Dr. Zhao hasn't seen it. Okay, so I put this up here, and for those who say, oh, God, I mean, because we make, I think maybe our freshman engineering students have to read a book where this is contained in this, right? So, and so everyone and so for those who so Dr. Zhao, if I could put you on the spot, do you see a younger woman or do you see a woman with more experience in this photo? You see what? You see a younger woman. Do you also see a woman with, like I say, more experience? Okay, so, and thank you for letting me put you on the spot. But so again, this image, and so Dr. Zhao saw, the younger woman where this is her chin, this is her nose, eyelash, and her hair. But, there's also the older woman where this is her nose, this is her chin, this is her mouth, and this is her whitish hair, or maybe something coming over that. And so my point of this, and I know this is, did you see it now or no? It's so this same image has a younger woman and an older woman. It's the same image. And it's just how you're looking at it. And forgive me for putting up this trite figure, but I've just seen it too much over the past 3 years in this issue alone to recognize this is the reality of this, of communicating with coal ash. People come to it from different experience. And so, the question then becomes, when you, from a technical perspective, how do you explain these to a colleague, like in the case of Brett Tempest here at UNC Charlotte, or a legislator in the case of Chuck McGrady, for example, others, a homeowner, right? Someone whose backyard overlooks a plant versus an attorney. And perhaps all of these groups could be listening to this subsequently. If they're not in the room, they didn't raise their hand. I didn't recognize folks. So the point is, they all are going to come to this with different perspectives. And look, in 2017, I'm sure there's like a gauge on this, but we've really bottomed out in trust levels, right? I mean, there's just there's a dearth of trust for a lot of institutions. And so this is an image showing the Animas River, and the EPA received a lot of blame for this as part of its work with dealing with acid mine drainage, and that impacted that river. Of course, Flint, Michigan, it doesn't get much worse than that in terms of a decision which is made and the fallout from that in terms of impacting people's water. I mean, it doesn't get any more basic than that, right? Everyone in this room depends heavily on our next sip of water. And so, but this is the milieu, this is the context that we're operating in. And that's, in the case of ash, of course, it's augmented by the relentless focus on calling things toxic and disaster and toxic sludge. And so this is, I mean, if you're fed that sort of information all the time, then it's very logical. It's very logical that you're going to have this sort of thing and a certain fraction of folks animated. Very logical, very understandable why people can, folks can be mobilized and be concerned. And it's also understandable why folks could be concerned when they live in proximity to an ash basin and wondering the extent to which their septic system might have an impact on their well versus an ash pond. I mean, depending on the information you hear and focus, it's going to give you a different result. And so this is all very understandable. However, it doesn't obviate or remove the need for us to unpack these issues, lay them out, and then move forward toward consensus. And data help, right? Data help when trying to forge a consensus, and it helps to have multiple people generating that data. So we were just chatting earlier. So this was some work from Duke University, where they'd gone on and done some testing, and notwithstanding the need for potential future work in this area, the high-level conclusion here was that, look, yeah, there's hexavalent chromium, and it occurs naturally. And this is really the crux of the issue for coal fly ash, because, yeah, coal fly ash has trace elements in it, and so does soil. And they occur at levels that are so similar that once you put it in the environment, it can be difficult to discern one from the other. Again, chromium is chromium, so whether it comes from a natural source or from an ash pond may not matter, but suffice it to say that this is a compounding issue in the case of coal ash. Not so much the issue if you're dealing with other impacts to groundwater. I mean, if you have a dry cleaning site and you've got trichloroethylene and you've got a very well-defined plume, then that's easy to understand, to characterize, and treat. Not so in the case of coal ash. This quickly gets difficult to discern what you're cleaning up and why. Likewise, UNC Chapel Hill has a wonderful website where they go on and look county by county across North Carolina and look at the suite of constituents that you're typical or likely to find in a given well. So how much arsenic, how much chromium, how much selenium, and they sort that up with average, mean, maximum values, and you can look that up by county or look it up by contaminant. But I'm not really here to talk about Duke or talk about UNC Chapel Hill. I wanted to give folks a sense of what we're actually doing here. And there are a million things that could be done. There's lots of things that are being done. And we're simply engaged in a fraction of that. And so my intent here, again, is not to grandstand. It's simply to inform and provide some clarity around what we're actually doing here, at least snapshots. So for the balance of the presentation, what I'm going to try to do, and hopefully this will, I don't see anybody sleeping. And if this were a class, I do go through the awkward interaction of waking people up. Doesn't seem like I have to do that just yet. But in the interest of trying to keep you up, we'll sort of rapid fire go through a few of these issues. And I'll say a couple of things. One, I'm taking a little bit of liberty by highlighting some of the work of my colleagues. So for those who look at this later, hopefully they don't cringe for my talking on their behalf. And likewise, a lot of this work is ongoing and active, and so further details I would simply defer to them. And a lot of this work involves multiple people, right? But I'm listing some of the key contact names. And so the goal here is to give a sense as to what we're doing and who's doing it at a high level. And so hopefully if I accomplish that, that'll have been faithful to the title of the talk and the abstract and your reason for being here. One thing I should point out is, look, we have to be open and honest. Again, it's a contentious atmosphere. And so one thing that does come up, I've given lots of talks, and periodically, in fact, I was just at a group called the English Speaking Union. I've never even heard of this organization, but it's an organization that's almost been around for 100 years and very eclectic group, a lot of which are journalists, for example. And question comes up, okay, yeah, that's a great job, but haven't you been funded by Duke Energy? And so the premise is, well, if you're funded by the utility, then your work is by definition favorable to them, or it's flawed, or it's by definition giving the answers they want. And I just need to be honest to those here and those who watch us subsequently that that's false. It's a false allegation. Myself as a researcher and UNC Charlotte more generally has been proud to do research for a whole variety of stakeholders. So we've done work for Duke Energy. We've done work for other utilities. We've done work for the Department of Transportation, the U.S. National Science Foundation. We worked with government agencies, local agencies, nonprofits. And so I would simply assert that, at least in my own case, I'm as proud of my work for Duke Energy as my work for the National Science Foundation or my work for NCDOT or anyone else. And furthermore, one can understand, at least from the public's perspective, there are lots of protections. One of the values, part of the value of doing research at a university is we are a public university. We do work for anybody. And furthermore, we've got very strict conflict of interest criteria, and then there's other protections as well. How many professional engineers do we have? Okay, we have a handful of professional engineers in the audience. It's interesting in the EPA CCR rule, they cite that credential specifically. So with this specific issue of coal ash, and this specific concern about, who's biased and this sort of thing, they say, you know what, as long as you're a registered professional engineer, we can trust you. Well, what if you work at the utility? We don't care. Why? Because professional licensure is a guarantor that what? That we're going to protect public health and the environment first, ahead of corporate interest, ahead of your own personal paycheck, all of that. So we could get into more discussion there, but I just want to acknowledge that directly. Some people sort of eschew this issue because it's awkward, it's uncomfortable. I'd rather hit it head on, and this would be a whole subject that we could deal with later. The pharmaceutical industry deals with a similar sort of thing as well. Anyhow, we got lots of folks who work with coal ash. It's not just me. And I should point out that a little over 30 years ago, perhaps our first ash-related work was with Roger M. Janardhanam. He worked with Flowable Fill. Published that in an ASE journal. But now we've blossomed. We got all these folks doing different work. We got several of them in the audience today. So when I get to your name, I'll call on you to correct me when I misspeak for you. And a couple of observations here. They're not all in any given department. So a lot of them are in, everyone's associated with EPIC. You're at an EPIC seminar. So I like to think that we're all associated with EPIC, and that EPIC is this platform and this umbrella where we all can sort of come together in a cross-disciplinary fashion. But you've got folks from mechanical engineering. And we've got folks from geography and earth sciences, and as well as other departments as well. So these are folks who've done it. So now what I want to do is just step through and give some examples of what we've actually done. So groundwater, and we've got Dr. Langley here. And by the way, forgive me for those who are in the audience. You're like, I know what it's like to be in the audience and have somebody else speaking on your behalf. There's this cringe factor. So I will try not to embarrass anyone. But simply try to convey, as is incumbent upon us as a public university, the kind of stuff that we're doing here. So in terms of groundwater, our resident expert is Dr. Langley. And this was a big issue, right? So you have 32 impoundments across North Carolina. They all had to be subjected to a process for developing what's called a comprehensive site assessment and developing corrective action plans. All of that involves testing actual soil and testing actual ash and pulling that together in a model. So half these sites were modeled by some folks at Clemson University. The other half were modeled in large part by Dr. Langley. And of course, there were other consulting organizations involved in this as well. I won't go into the minutiae of this. But certainly we had involvement there. But all of these sites required actual field sampling of actual soils and testing those soils for how they behave. And all that was done here under the direction of Dr. Langley. And so that involves lots of soil samples. This is actually from a different project, but it does convey how much material we've had coming in here. We've had literally tons of ash come through here, tons of soil. This was refrigerated storage that we had for about a year and a half, where samples would come in, would be collected, would be stored at approximately 4 degrees Celsius. So a lot of material came through here. And then a lot of work was done with column experiments, basically saying, okay, you've got an ash pond, and your concern is the mobility of, I don't know, pick a constituent, boron or selenium or whatever your concern is. How is that percolating through the soil, and how can we quantify that? So lots of experiments done, and then once we do that, we're able to go on and incorporate that into a model. So once you know where you've got material and how it's leaching, you're able to build a three-dimensional model. And you can do that in plan view. You can also do that in profile view. So these sort of, they almost look like cartoons, I guess, but they actually reflect a fair degree, well, they reflect an enormous amount of data, and then a reasonable amount of computational horsepower in terms of integrating field-relevant data, laboratory data, pulling it all together, and then making projections. And it's something that, and this is sometimes lost, data collection and even modeling is always an iterative process. And so you start with your initial assumption based on reality as best you can determine it from actual field data, and then you integrate that with greater resolution of data, refine your model, and go further through the process. And so that's essentially what's going on here, and we've been involved in that effort. The result of such effort can help with predictions in terms of, okay, well, depending on how much boron sticks to soil or how much arsenic absorbs the soil, what would be the prediction as a function of time? What does that concentration look like with time? So that's the significance of testing those soils, is trying to find out if you've got a groundwater limit of, 700 micrograms per liter, are you going to hit that threshold or not as a function of time? That's the purpose of that data. Likewise, you can explore scenarios. And so you're going to get lots of different answers depending on where you look. So in this case, you've got a graph which implies that for a given concentration for a given time, that excavation gives you better results. If you want to use better, if you want to use lower concentration as the definition of better for that location, for that site, or on the same site, a different location, you can get radically different results. And so here you get for same constituent, right? Yeah, same constituent, different location, virtually no difference whether you excavate all that ash or leave it in place and cap it. But modeling can be a tool in that. So my point now is not to make a case one way or the other there, but merely to say get the data and help that inform your discussion. So these are publicly released results of that, but the results of that kind of work then allowed our utility to go on and make projections as to what was the impact of these ponds and where's it going. So this is plan view, right? And this is profile view showing, okay, if you have an unlined pond and you've got a slope aquifer system, you've got groundwater flowing toward the nearest river, and here's your impact. And so this then can be used to the extent you have to look at corrective action, post-closure monitoring, this kind of thing. So that's all groundwater, and Dr. Langley was involved in that. So physical strength and stability. I don't know if Dr. Pando's here. Another question that comes up is just what about the strength of the material, the strength of the subgrade soils, the strength of the dam, the strength of the ash particles, and how does that behave dynamically? And so our resident expert there would be Dr. Pando, and he has done work for several utilities as well as the National Science Foundation, but in particular with regard to ash, has done work on undisturbed samples of ash and simply tracking that behavior. So for the same reason that you might want to be able to make predictions for groundwater quality and quantity, you want to do predictions on strength subjected to different kinds of scenarios, different kind of earthquake events. And so this is work that Pando has done. Okay, so what about, and again, remember, we're stepping through a series of vignettes here. Some I'll go into more detail, some less, depending on what I've got available to me. And that includes, when I say available to me, that means both expertise as well as resources from the folks working this. But water balance is an interesting thing. If you think about alternative covers, we generally think, oh, gosh, if you don't want water to get in there, then you got to have some geomembrane, some thick piece of plastic and prevent infiltration. So if you have a waste and you want to prevent infiltration. But you can also look at this through the lens of water balance. You've got a certain amount of precipitation, you have a certain amount of evaporation, you have a certain amount of transpiration. And so we can engineer with these things. I know Dr. Kulasingham and others know a lot about this, but point being is you can engineer with this, and this would be Dr. Kire's expertise. And so looking at that, you can develop guidance. And so this is not for North Carolina, but this is something that recently got approved just this month, just this year, for Texas. So this was not done for coal ash, but it applies in the sense that you can break up any geographical region in terms of precipitation, right? So they get more rain on the eastern part of Texas, not so much over here. And you can use that information to say, okay, for a given precipitation event, how much soil do you need to prevent infiltration from getting further, because it'll hold it. And so he's developed charts through lots of different testing, field-relevant testing. And so he's got plots that have informed this regulation, which give you the thickness of a storage layer that should be used at different locations. So if you're in Lubbock, Texas, or in Houston. So just what you're looking at there. So if your thickness of your storage, as you increase your thickness, then you get less percolation through the waste. And then, likewise, you've got a drier area here and a wetter area here. So you're going to have more percolation where you've got more rain. But you can use this and use actual data to then give you an alternative approach if your goal is to control infiltration. Okay, so that's Dr. Kire. How about Dr. Tempest? He's more of a structural engineer. I don't think he's here today. And so he's got ongoing work as we speak dealing with how to work with ash that's, shall we say, off specification or has high carbon content, for example. So ash is desirable for concrete. It makes concrete more durable. It's particularly helpful in the summer where it lowers the temperature and allows pores to occur in the hot summer months. So he's got active work where he improves, looks at the effect of different ash types on concrete performance. A couple of years ago, so he's doing that actively. Going back a couple of years, of course, he was instrumental in putting together our solar decathlon. So this was our Department of Energy competition. This is where we competed along with other schools in the Department of Energy and built a house with concrete panels with no ordinary Portland cement, entirely coal fly ash. So that's sort of his work, and it's significant in the sense that this is the #1 reuse category for ash. So if you look, and I just pulled this up yesterday from the American Coal Ash Association, they keep the statistics. The most recent ones are 2015, and the vast majority is in using ash as a partial replacement for Portland cement. One thing you can look at is a lot of states maybe use 20% as a max. Can we push that to 30% or more? And so this is the kind of work that Dr. Tempest has done and does to see if we can get more of, so if we had 44 million tons of ash produced in 2015, 19.3 million were used, can we improve that? Can we increase that fraction by understanding the properties? And it's, this isn't like ivory tower speculative stuff. This is impacts the bottom line. In fact, right now these kinds of emails are occurring. This is from 2016, but I get periodically you'll get these emails where there are concerns by contractors of not having sufficient ash or having to import ash from another state. Why? Well, because, yeah, there's a lot of ash here, but it doesn't necessarily meet the specification that they need. So this isn't meant to be read, but I guess what I'm trying to point out here is, I guess I'll read this point here. They were notified that these folks are increasing their allocations. I mean, they actually had to ration ash because there just wasn't enough of it, in part because there wasn't enough of the right quality. So in North Carolina, we got a lot of ash, 150 million tons, depending how you count it, plus we're generating some more every year. But the market, on the one hand, the market is low. On the other hand, sometimes we can't even reach that market with our ash because of the quality of the ash. And so this is where I would suggest more R&D can be helpful. But if you're going beyond concrete and if you're just thinking about ash use, for example, I've gone on record saying that in addition to the Asheville Regional Airport, you could use ash at the Charlotte Douglas Airport, use it a lot of other places. But liability issues come up. And so in my mind, this harkens back to the need for sort of like a brownfields type program. And for those who are familiar with that, we could get into that. But anyhow, those are some issues there. What about new products? This is something that I find fascinating as well as exciting. And so Dr. Ahmed Al-Ghanem, professor of mechanical engineering, sitting here with us today, has done, not only had the idea, but got the ash and made the material. and so went on and tested samples of ash. And by the way, correct me where I err, Dr. Al-Ghanem, but vitrified the material. Yeah, so took the ash. There's some pre-processing of the material and then generating through vitrification and some other processes a material which has fantastic properties, really unique properties that allow for this material to then be used in solar panels as well as other applications as well. And of course, concerns for leachability, gone, it's vitrified, and then it's got engineering properties that are desirable. Let me pause there. Anything else you want to add to that since you're here? So zero, so in addition to the desirable engineering properties, when evaluating leachability, zero concern on those constituents. They'll have that correctly. And thank you for, I won't be able to repeat that in its entirety with accuracy, but let me just summarize that since I'm being recorded and I think this is being played subsequently, by saying that you've gone on and done some initial financial feasibility analyses. So in addition to being technically plausible, financially feasible, there's great potential in this sort of application. Yeah. So there you go. And there's and that's what's going on here. Again, my intent is not to talk about fly ash generally, about all the things that could be done or would be done or are, but here. And so that's one example that's being done here. Dr. Gunra, who is also here in the back right, he is leading our effort in terms of what we might call paste stabilization or paste technology. And this is also fascinating because it represents a paradigm shift with regard to ash management. And it's a shift that's brought on in part by the confluence of two sets of regulations. You got the management of coal ash and the closure of ash impoundments. That's great. But then you got this thing called the effluent limitation guidelines and wastewater criteria, what can be discharged. And so if you look at the net effect of very strict criteria on what can be discharged from flue gas desulfurization streams, waste streams, then you're left with a very high salt mix. And so the notion is, can you take that very high salt mix, so like if you take this wastewater and you concentrate it, you're essentially left with a brackish, briny salt water, if you will. And then can you take that and mix it with ash and stabilize it? Lots of work has been done on stabilization here and elsewhere, but this is radically different in the sense that you've got material that wants to be in the aqueous phase, so halides, fluorides, bromides, chlorides. You have constituents that want to be in the water phase. They don't want to be in the solid phase. Can you sequester them in the solid phase by mixing them with ash? And so what you end up with is this notion of a paste. And so we're almost going full circle in the sense that it's kind of like flowable fill as far as a consistency. But the reason why I say this is a radical departure is because for decades we would have ash impoundments, and we're clearly getting out of that business. And then what I said earlier is, well, now we're going to dry ash landfilling, and so you're basically taking ash and compacting it like an earthen fill. This is a whole new mode, the rheology, the workability, how it actually would be conducted at a plant is different. And there's a compelling read to look at this, not just by us, but other organizations, the Electric Power Research Institute and others, looking at this as a possible way to manage these two waste streams so that you're taking the wastewater and you're mixing it with ash, and then you're trying to sequester things. And so the notion would be, instead of building an earthen fill, you're almost back to an impoundment-like structure, but now one that solidifies. And so what you're looking at here is, after an initial round of solidification, you would have another layer deposited on top of it. And the trick is not just to make this, because this process exists for mine tailings and this sort of thing, but it does not exist for taking ash with brine wastewater. Again, the whole point of this plot is to show that these things that are in that wastewater want to stay in the aqueous phase. Now I'm keeping an eye on my clock here because I want to keep people, anyone sleeping yet? I want to keep people awake, and I also want to finish on time. So what Dr. Gunro is doing is, and him and his team, it's him and others, Dr. Langley, others working with him, looking at, okay, what phases are occurring? How can we take fluoride, bromide, chloride, and combine them into a new mineral structure? So that involves looking thermodynamically at the potpourri of reactions that can be controlled and facilitated to sequester some of those constituents, and then validate that by actual images and try to see, okay, where are these minerals? So thermodynamically it should happen. I go on and test it. Lo and behold, it's there. And then, of course, you also have to scale this up to the field to make sure it's actually occurring. My work is on water repellency, And I'm going to move through this pretty quickly, but my general notion is if you're concerned with, water is the source of all kinds of issues in geotechnical engineering. Water tends to reduce strength. It tends to increase swelling. It also can contribute to leachability. So if you can control where water goes, then ostensibly you can improve the performance. So I work with a class of chemicals called organosilanes. We've got some other folks in the room who have done that with me. And I'm not going to play this for you, but you can transform any silica-based substrate to something which is water loving to water repelling. And so that's the general idea of what we do here. And so we measure that with contact angles and then with breakthrough pressure. And so without walking through all this, I guess what I would simply suggest is we can now take a sample of ash, treat it with organosilane, and then that sample of ash can support several meters of water without penetrating through it. Now, there's lots of questions in terms of the ash type and the durability and again, it's research. But this has been going on at this point. I've been working in this particular area for 10 years now. We're still making advances and getting good recognition from the work we've published thus far. So I'm going to skip through that because I also want to be mindful of time. It's 20 after. I want to leave some time for questions. I do have work on this Ash Management Advisory Board. That's one of the reasons I'm spending more time on that in this particular year. And so this is a board of experts. This board exists principally, utilities and organizations often make use of boards. That's not unique. Lots of utilities, make uses of boards. And similarly, we have government panels, government commissions. But shortly after Dan River, there was a desire to create a board to just review things and to those issues where they were going to have implications run through a board of other experts. And so I chair this board and have some other folks working with me. And again, we're independent, and we're not spokespersons for the utility, and we've got different expertise according to the needs. And what's happening now for the advisory board is it's widening its scope. So this started as an initiative for Duke Energy exclusively. Now the advisory board is opening itself up to engage with other utilities as well. And the general notion is that you've got a whole litany of issues, and the advisory board's not meant to get into the weeds or the minutia of activities. The fact is, utilities such as Duke Energy have outstanding subject matter experts. They have excellent consultants, excellent contractors. They have more than enough capacity there. However, there is a fraction of issues. There are some issues which benefit from being routed through a third-party independent group to say, hey, does this make sense? What else are we missing? What else should we be doing? And it's more of that sort of a feedback loop, not unlike we do with things like accrediting boards, where you have, or other panels and other review boards which can provide that kind of feedback. So that's the idea. I mean, one thing I like about the board is, the credentials, the experience. The idea is to be aware but detached from, say, corporate momentum, and to be able to challenge assumptions and ask questions and ultimately be helpful. I mean, the goal of the board is to be helpful. And so the kinds of things we've looked at are like, okay, I mean, should you be capping this in place? Should you be excavating this? And how does that relate to things like sustainability? So just to give you one example, what the board's really pushed for is to look, quantify your impact to sustainability, quantify things like life cycle analysis, net environmental benefits, this sort of thing. I mean, do you really need to excavate that? This is an ash pond, and by law, maybe. But from a science perspective, maybe not. So there is a difference between an advisory board and a research center. Again, the advisory board, the work I do is primarily as a reviewer. We're not doers. And so that would be a difference. I'll move this along here. We got it's 24 after. So separate from that, and this will be the final item I want to talk about, is the Coal Ash and Liquid Management Office. And part of my reason for doing this, one of the reasons when David Young said, well, gosh, do you want to give a presentation on this? We have so much going on that it helps to have some awareness of what different folks are doing and how they relate and how they don't relate. So we have the Coal Ash and Liquid Management Office that's run by Chris Harden, who's here and who introduced me, and Malin Kire. And this is principally an applied research center. It was originally envisioned to be an NSF, Industry University Cooperative Research Center. The idea is that you have members put in money, and they invest that money and direct research that helps solve issues within the industry. That's the model, and it would be complemented by NSF. That was the original goal. It's evolving on its own trajectory thus far without NSF funding. This is just a picture from last week. Chris, hope I don't embarrass you, but running a series of meetings widely attended by a broad cross-section of stakeholders. In my opinion, Chris may disagree. In my opinion, this sort of the initial impetus for this has really been the folks moving the ash. I mean, we're trying to move a lot of ash in a short amount of time. And you have actual people in actual equipment making actual decisions on the ground, and they have questions, and they have things that need to be resolved. And so that was sort of the impetus for this, to help resolve some of these questions that folks who are actually moving the ash are experiencing. And it's a lot of ash. And so I did get permission to use these slides, but the point is, you can't simply go in and excavate these things on an arbitrary timeline. You do have to make sure, just like everything else, the science and engineering informs what's being done and how it's being done. And so, the one controversial statement that sometimes gets put out, and I don't think it's controversial, I think it's a matter of interpretation. I would agree with this statement that ponded ash is an excellent geotechnical material. I mean, I started out this talk by saying ash is a great construction material. Even ponded ash is a great construction material. However, you do need field-relevant data. I mean, it's like everything else in life. You got to do your homework. So, I mean, just because it's a great material doesn't mean you don't have to evaluate differences between lab and field, you still have to do your homework. And so this is how I would sort of reconcile, and some of the room know what I'm referring to, this messaging issue on ash in terms of its geotechnical properties. So with that, I think this is going to be my final slide. And I got this, we get countless emails from ASCE and other organizations, and I thought this was interesting. And it's, focusing on flawless execution is destroying innovation at your company. And so, look, I get that. I mean, we're a university. Sometimes things are messy. Sometimes when you engage in an issue that has tentacles that stretch into so many different parts of the population, and then with different perspectives, and then with different motivations, things will get messy. And the hope is that, of course, ultimately, we sort through that. And so my sort of solution to, not trying to aspire for perfection in terms of how all these activities align together, but you have checks and balances. And so we're a large enough group that we do have checks and balances on each other as needed. So with that, I want to thank you for your attention. I'm grateful for your time here. And if you have any questions, let me know. Although I apologize, there's only 4 minutes left until the scheduled end. So hopefully it's a really good question so we can get it recorded. But thank you very much. Thank you. Any questions? Corrections? Yeah, Chris. Okay, so we actually have a little bit of time then. Okay. Okay. Okay, so Chris just said we can go to 1:40. I mean, you might not be able to stay till 1:45, but I'll stay here till 1:45 if questions go that long. Thank you, Chris, for that clarification. Questions, comments, concerns? Yeah. Yeah. Just prolonging the process? Well, I think the intent is to have it permanently stabilized, whatever permanently means. And, we just happen to have Professor Ogunro in the audience, and I'm going to happily punt that question to him. Dr. Ogunro, the question is, okay, this PACE process, that sounds great. Are you just prolonging the problem, kicking the can down the road? And that goes a long way to making sure you know what mineral you're forming and quantifying the thermodynamics and how those thermodynamics could change through time, that and kinetics. But so it's a big question. It's hard to answer that in a soundbite. It's a great point. Other questions? Yeah.
John, just a comment, I think, because you threw up an email from one of the cement companies.
Yeah.
I don't know if...
You don't know if you agree with that?
maybe, no, I agree with you. The emphasis would be, though, that the cement companies are really worried about the decline in coal production,
Yeah.
electricity generation from coal, because that fly ash is very inexpensive to them to put into their cement.
Yeah.
And they have to find a substitute for that, which is expensive.
Yeah.
That shows up for us in building costs and everything else.
Yeah.
So it's really an economic problem for the cement concrete.
Yeah. What's that? Yeah, you burn less coal, so there's less ash, yeah. Thank you. Other questions, comments, corrections?
How about one last question?
Yeah.
I've been reading a little bit about centispheres. Is that a subject matter that you or your colleagues are looking into?
You know, I have not. You know, certainly we've done a fair amount of characterization of ash generally, but not focusing on the centispheres. And obviously that's for those who don't know, I mean, that's if you've ever gone to an ash pond, wherever the wind's blowing, you'll see this fine accumulation of white particles and the very light, hollow centispheres and have wonderful properties, niche properties. I myself have not done work on that, and I'm not aware of anybody who's actually worked specifically, exclusively with centispheres. I'm looking for Vincent or I don't think anyone in our group is focused on centispheres. Certainly there are research groups who, perhaps you're aware, have done a lot. That's not something that we've done here. I don't know if you have an experience you could share.
No experience yet, just looking into it. On a worldwide scale, there's a good bit of centisphere harvesting going on.
Right.
The point is, it's got some very good niche uses.
Right.
Enough so that power companies that have full ash ponds are harvesting it for benefits.
Right.
Economically, what do you use them for?
Centispheres? Well, I mean, they're lightweight particles, right? I mean, so they can be used in coatings. They can be used. Makeup. Okay. The other thing we're not doing, again, not to shine a light on what we're not doing, but again, my goal here is clarity. The other issue, it's probably just worth mentioning, is rare earth elements. To my knowledge, nobody on campus is working on that. The U.S. Department of Energy has a large program aimed at funding universities, which are actively doing work now. Can we harvest things, rare earth elements from the ash to help with things like cell phones and other devices and use it as a source? So to be clear there, so how this looks, so you know, we have faculty doing research, and then you've got this CALM office, which is an entity where you've got members who are part of this group, and so that tends to cast a wider net, right? Because now you've got a group, and you've got vendors, you've got other members who are part of this office, and so that casts a wider net in terms of awareness and activity, and so you know, that's all going on perhaps as part of the CALM office. I'm just making the distinction that to my knowledge, there's no faculty actually doing research on the rare earth, but certainly folks maybe that Chris is interacting with are. Well, we did have, and I would be remiss, let me at least mention it here so I don't feel bad, but we did have a startup company in Portal whose focus was to stabilize the ash and to mine some of the trace elements. And, you know, if this gets broadcast later or a comment goes to the rumor mill and the grapevine, my apologies for not reiterating it, but there was a startup company and involved some folks from UNC Charlotte, and they had a process, a patented process for simultaneously sequestering it and also extracting that which is usable. I have no idea, I can't even remember the name, but so other questions, comments? So the WIN Act specified that states can, and I'm going to get this not 100% correct, but you know, you have the CCR rule, and absent the WIN Act, you simply have to you know, follow the rule, and if you don't, it's up to citizen lawsuits to. Now, the WIN Act says, hey, you know what? States, you can adopt the rule. You can make it a permitting program. So once it becomes a permitting program, then you're a utility. You can get a permit, and that should be more predictable and more consistent and less subject to the vicissitudes of plaintiffs hither and yon trying to make a judgment on how you complied with that part of the CCR rule. Rather than do that, you now have a permitting program. So that's what DEQ's, you know, and so there's some discussion of how that's being done. But now DEQ can have a coal ash permitting program instead of just relying on citizen suit enforcement. Does that make sense? And that's part of that WIN Act. That just December 26, just 4 months ago, 3 months ago-ish, is, you know, that became available. Does that make sense? Okay. And I'll tell you one other thing. My hope, I keep saying this until somebody tells me I don't make sense. My hope would be that that opens the door for risk-based corrective action, because the CCR rule does not, strictly speaking, allow that. And so that would be my, I mean, I've made that point often. So that would be, and that would be significant. Do you have to meet a certain groundwater concentration right here, or can it be in the context of risk-based corrective action like we do every other kind of waste on the planet? Okay. Other comments? No other comments? Criticisms? You know, yeah. 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 Yeah, I mean, you know, that's a wide subject. I mean, I would simply assert that, look, coal comes from the ground. You've got trace elements. Coal ash does tend to have more of those than soil on average. But again, the concentration that you have is one that is not, if you look at EPA's definition of toxicity, one that exceeds that. And so, you know, as your question implies, Chris, you definitely need a threshold of certain nutrients. That's not my expertise. That would be more the expertise of a guy like, you know, like a soil scientist, someone who specializes in agronomic rates of application and that sort of thing. But, you know, look, I would simply assert that, like everything else in this domain, get your data and, you know, make your decision based on the data as opposed to broad based assumptions where, to your point, Chris, I mean, this notion of, well, gosh, we've got arsenic there, we need to ensconce this in a new landfill. Well, maybe not. Yeah. Other comments or questions? Okay. Well, thanks for coming. Hope you got something out of it. Thank you.